So to start with, like we said, maybe one way to think about this is to just do the full formula for the cube and the full formula for the pyramid and then add them together. So the full formula for this green cube down there would be pH plus 2b, where P stands for the perimeter of the base. So we're going to do 6 plus 6 plus 6 plus 6. So in other words, 6 times 4. Then times the height, the distance between the bases. I called my bases my top and my bottom. So my height was 6 plus 2 times area of the base. And so the area of the square on the bottom was 6 times 6. Then for the pyramid, the formula is 1/2 PL plus B. So we're talking about 1/2 perimeter of the base would be 6 times 4. Again, so we're doing this base now, but it's still 6 all the way around, times 4 sides, times my slant height, my L, and it tells me in the problem that my L is 6, my slant height going down the side there, plus the area of the base, 6 times 6. Okay, then what I did is once I had the entire surface area of both figures put together, is then I went through and subtracted out the parts I didn't need. So you've got to think about, like, if you were to take this whole composite figure and you were to dip it in paint and bring it out of the paint, what parts of these shapes would not have paint on it? Well, you wouldn't have paint on this inner square there. Because it's on the inside. And so we have accounted for that area here and then also here as one of the bases. So what we need to do is subtract off 2 squares. We have to take off 1 square for the bottom of the pyramid, so one of the 6 by 6s, and we have to take off a second square for the top of the cube. So a second 6 by 6, which gives you a grand total of 252. Let's go look at number 3. So I used the same strategy here. So I did the entire cylinder, which is 2 pi RH plus 2 pi R squared. I did the entire cone, which is pi RL plus pi R squared. And then I added them together and subtracted out the parts I didn't need. So let's look at what that looks like. So if my diameter all the way across this circle is 26, then that means half of that, my radius for these top and bottom circles, will be 13. So for the cone, we have pi times radius of 13 times we don't know our slant height. Our slant height would go from the top down to the bottom rim down here. And this, at first glance, I'm thinking, oh, that's a 5, 12, 13. But remember, that only works when your hypotenuse is the biggest number. So you can't use a 5, 12, 13 triple here. You have to actually do the Pythagorean theorem. So that's what I did over here. 12 squared plus 13 squared equals L squared. And 12 squared plus 13 squared comes out. Okay, so in 5, 12, and 13, on a right triangle, 13 has to be the longest side. Your biggest number has to be the hypotenuse. So 13 in this case was the bottom, which was indicating that there has to be a bigger number on the hypotenuse. And 5 nor 12 is bigger than 13. So that wouldn't be possible. It all goes back to that rule about small angles are across from small sides and big angles are across from big sides. So since 90 degrees is the biggest angle in this triangle, it has to be across from the biggest number. Good question. So once we get our slant height to come out to be square root 313, or approximately 17.7, plus pi times 13 squared. Let me put that in my calculator. pi times 13 times 17 point, well, I'm going to use all the decimal places. Square root of 313 plus pi times 13 squared. Just that part of the formula comes out to 1,253.47. Then when we go to do the cylinder, which is a little bit easier because we don't have to solve for slant height, we have 2 pi times 13 times my distance between my circle bases. My height is 10.5 plus 2 pi times radius, which is 13 squared. Pi times 13 times 10.5 plus 2 pi times 13 squared. That part comes out to be 1919.5. And then when I think about what surfaces are touching air, or if I think about if I dip this whole shape into paint, what would come out without paint on it, you need to be thinking about this inner circle right here. That circle would not have paint on it, and that circle is both the bottom of the cone and it's also the top of the cylinder. So I have to subtract out those two circles. They don't count in an outer surface in surface area. Remember, volume is the amount of stuff you can put in here, but surface area is the amount of outer surfaces you have. Okay, so this would be 2 pi times 13 squared. Okay, and so I'm subtracting that from my two other numbers added together, the 1253 plus the 1919 minus the 1061.858, and that comes out to 2,111.1 centimeters squared because it's area. What questions do you have about that one? Okay, and then number 4, this one was also tricky. On this one, you had a hemisphere, a cylinder in the middle, and a cone on the other end. So hemisphere, cylinder, and there's the formulas for those. Hemisphere is 2 pi r squared. Cylinder is 2 pi r h for just the lateral area. So same thing for the hemisphere. On this one I used a different strategy. Instead of doing the whole thing and then subtracting out the parts I didn't need, I just started off the formula without including the parts that I didn't need. So normally, for example, the cylinder is 2 pi r h plus 2 pi r squared, but these 2 pi r squareds represent these two circles, which I knew I didn't need because they're on the inside of the shape, so I just left them out of the formula to begin with. So that's a different way of handling this. Same thing with the cone. The formula is normally pi rl plus pi r squared, but this pi r squared is the bottom of the cone, and I knew that because it was inside the shape, I knew I didn't need it, so I just didn't include it. And then for the hemisphere, half of a sphere without that lid on it, without that circle base, is 2 pi r squared. So my radius was given to me to be 2. So I went ahead and pulled that in, 2 pi 2 squared. My distance between my circle bases on the cylinder was 8. So 2 pi RH was 2 pi times 2 times 8. And then the cone is the hardest part of this whole stinking thing because you don't know your L. You know your radius is 2, so you go do pi times 2. But let's talk about how you find L right here. So we know that this is 2 because it was 2 over here. Here's the weird part about how to find the height. You know that this is 2 because it's a radius of the hemisphere, so from there to there is 2. You know that from here to here is 8 because that was given to you on the cylinder. So you have a 10 total, and then you have 5 left because this was 15 total, and you'd used up 10, so your height has to be 5. So then that's when I came over here and did the Pythagorean theorem. A squared plus b squared equals c squared. So 2 squared plus 5 squared equals L squared. So L came out to be square root 29, which I plugged in here, and then put it all in my calculator to get 159.5.